In my previous video, we talked about combining these two fractions together to give this single fraction, and now we're going to reverse that process to go back to the two separate fractions, often necessary for integration. So we're going to start with this fraction here. So we've got 21 minus 13x divided by 2x plus 1 times 3x minus 5. And reversing this process is a method referred to as partial fractions. And there are three types of partial fractions that you need to know for the A-level course. And then there are some others which could come up in the exam. So we'll have a look at some forms a bit later on in the video. But for now, I'm just going to talk you through this process. So one of the forms you need to know is if you have a linear divided by the product of two linears, then this can be written as some constant divided by the first linear plus another constant divided by the second linear. And our job is to find what the values of these two constants are. And this is actually an identity. Okay, it's true for all x, which we're going to use that feature in a little bit. So the first thing we're going to do is take this identity and we're going to multiply the whole identity by the denominator of the left-hand side, and that will get rid of all my fractions. So multiply the left-hand side by the denominator of the left-hand side. It's just going to leave its numerator. So that's 21 minus 13x. And that is going to be identical to a multiplied by 3 minus 5x. So what's going to happen is the 2x plus 1 is going to cancel top and bottom. And we're left with the a times the 3 minus 5x. Similarly with the b, this time it's the 3 minus 5x that disappears, and we're left with 2x plus 1. At which point there are two methods that we can use to find the values of a and b, or at least two methods I'm going to be talking about today. One of them I refer to as substitution. So method 1 is substitution. And method 2 is a little bit more mathematical, is equating the coefficients. Okay, equating the coefficients. So method 1. This identity is true for all values of x. So we just need to choose two values of x to substitute into this to give us a pair of linear simultaneous equations in a and b. Once we've got those, we can solve them using whatever simultaneous equation solver you fancy. However, we can actually be fairly clever as to what value of x we choose, because actually we can, in this case in particular, design it so that we don't have a pair of simultaneous equations, but we actually just have two separate equations, each with a different unknown, one with a, one with b. So what I'm going to do is, first of all, I'm going to sub in x is 3/5. And the reason I'm choosing 3/5 is because that's going to make this bracket 0. Okay, if x is 3/5, then I'm going to get 3 minus 5 times 3/5. Well, 5 times 3/5 is 3. 3 minus 3 is 0. So that disappears. Which means I have no a, and I'm left with just a linear equation in b. So 21 minus 13 times 3/5, so it's going to be 39/5. Let's keep it as fractions for now. And that is going to be equal to b times 6/5 plus 1. Well, 1 is 5/5, so that's 11/5 times b. Okay, that's now a linear equation in b. It's going to times it by 5. So 105 minus 39 equals 11b. 105 minus 39 is 66. 66 divided by 11 is 6. So I get that b is 6. I could do something similar, but to make this bracket 0, I'd need to choose that x is minus a half. And then I get 21 plus 13 halves. Okay, the minus and the minus have combined to make a positive. and that is going to be equal to 3 plus 2.5 is 5.5, or 11 fifths. Sorry, 11 halves. Times that by a. I'm going to take this equation now, multiply it by 2. I get 42 plus 13 equals 11a. 42 plus 13 is 55. Divided by 11 is 5. So I get that a is equal to 5. Once I've got my values of a and b, I can then state my answer as being 5 over 2x plus 1 plus 6 over 3 minus 5x. Okay, that's my solution. So I've written this single fraction now as two separate fractions, which are the two fractions I actually started with in the previous video. Method 2, equating the coefficients. Because this is true for all values of x, then the coefficient of x and the coefficient of x to the 0, i.e. the constant, they must be equal. So let's first of all look at the coefficient of x, so x to the 1. On the left-hand side, it's minus 13. Okay, the coefficient of x is just the number that multiplies by x, so minus 13. Here I've got minus 5a, and here I've got 2b. So that gives us one equation in a and b. Similarly, the coefficient of x to the 0, i.e. the constants, they must be equal. On the left-hand side, it's 21. And on the right-hand side, I get 3a plus b. Okay, a pair of simultaneous equations in a and b, so I can solve those. So I'm going to do this top one, subtract 2 times the bottom to make the b 0. So minus 5a subtract 2 times 3a gives us minus 11a. Okay, the b's have disappeared. Minus 13 minus 2 times 21 gives us minus 55. Divide both sides by minus 11, and that gives us that a is 5. And once I've got that a is 5, substitute it back into either one of these, and that will yield b is 6. Okay, 3 times 5 is 15, plus 6 is 21. Minus 5 times 5 is minus 25, plus 12 is minus 13. Now that I've got a and b, I can write my answer as 5 over 2x plus 1 plus 6 over 3 minus 5x. So whichever method you choose, they both come to the same solution, and the exam will never ask you for a particular method, so you are at your leisure to choose which you prefer. So that's one type of partial fraction. So that's if you have a linear divided by the product of two linears. Other ones you need to be aware of. If you have a quadratic divided by the product of three linears, then you need to know it can be written like that. That's the one we've just done. So a linear divided by the product of two linears. And then this one here is if you have a repeated root on the bottom. Repeated root on the bottom means that we have this situation as opposed to this one. And that is because if we didn't square this one, then we could combine the b and the c together to give one constant, which isn't enough because we need 3 constants for this one because we have 3 coefficients to equate. There are some other ones that can come up, so there's a couple of them. You don't need to know these ones off by heart, but they can be brought to you in the exam. They will say, given this can be written as this, find A, B and C. Okay, A, B, C, D, E, F and G, they're all numbers that are given to you. Similarly for this one. Okay, so you've got quadratic divided by the product of a linear and a quadratic, such that that doesn't factorise and doesn't have a linear term. It can be written as that. And then this one here, quadratic divided by the product of two linears, can be written as this. Subtle difference between this one and the The one I did, okay, it's got a quadratic on top, not a linear on top. Okay, but there are many others that can come up as well. But the same process, multiply through by the denominator of the left-hand side, and then either use substitution or equate the coefficients to find the values of the constants.